Hello my dear champions, I hope all of you are doing great. So today I'm here to discuss another two chapters, the last two chapters in your PU1 syllabus in the Master's Book series. And the chapters are Statistics and Probability. Simple ones, okay, straightforward formula based chapter. This theory itself will help you a lot. Standard deviation, difference in the standard deviation and variance when the data is moved and all of that type of category is question over here. How to find central tendency and everything will be discussed in this particular chapter. And probability, of course, the basics of probability only is there in this PU1 syllabus. So try to learn and give complete focus in these two chapters, theory lecture, because even the theory lecture can help you score good marks from these two chapters. Again, statistics comes for 1 mark, probability can come for 2 marks also. So relatively 3 marks are over here. So be serious when you are learning these two chapters. Again, so to solve more questions, you can watch us. I have done this chapter covered in 15-day challenge. I have done the 3 sessions of PU1 as well. You can go and refer that. Okay, and if you want to solve more questions, you can refer our test series. ABHYAS test series is available at 999. Okay, so I think we are ready. Let's start the class. Let us look at now the one-shot lecture, the theory lecture of the chapter Statistics. Some formulas based approach is there. I've taken some questions also, but we'll cover up everything. Most of the thing over here is about definition and type of events. Okay, so we'll focus on that, but we'll go through this very quickly. Let's start. So measure of central tendency. Very easy. What is that, sir? So mean and median, and one more is there, mode. What is mean, sir? So average of all. Definitions and notes you will get. Please access and start working on it. What about median, sir? Median represents once you have the data which is given to you, grouped or ungrouped, you arrange them in the ascending or descending order, and the middlemost value is called as median. Mean is the average. Okay, guys. So median, middlemost value is median, and the formula to find it is very simple. Value of, if it is given, if there are n as odd number of terms, excuse me, if you have odd number of terms, then n plus 1 by 2th observation after arranging in ascending or descending order. As I mentioned, after arranging in ascending or descending order, if it is odd number of terms, then this observation will be your median, and if the number of observation is even, then you're going to find the median using this, half of the value of n by 2th term plus the next term. Let's say n is 10. Okay, so n by 2 will become what? 5. If n value beta is 10, n is number of even terms. Okay, by the way, this becomes what? 5th observation. So 5th term plus this will become what? 6th term. I know some of you might have confusion in this. So whenever you have an even number of terms present in a given data set, first job, arrange them in ascending order. Next job is take the middlemost term, which is going to be half of that, plus the next term, 5th plus 6th term by 2. So answer will be that only, 5th term only. I'm not saying 5 plus 6. Please don't write median as 5 plus 6 by 2. This is wrong. Okay, 5th term plus 6th term by 2 is what I'm asking. Okay, next, if you talk about mode represents basically the data with highest frequency. Okay, that's the easiest way to remember it. Whichever occurs the maximum number of times is called as mode. Some important relations that you have for sum of n natural number. This represents sum of n natural number. Sum of n natural numbers. This represents sum of squares of a natural number. Sum of squares. Actually, this all is for first. Okay, squares of first and natural number. Okay, this also, first one also is for first only. Okay, I do not write that. This is the cube of the first and natural number taken as sum. Please remember this formula is important for all of you. Now, so in the syllabus we actually talk about, we move from here. I'm not saying we don't use it only. We do use mean and median, of course, but we cater to the dispersion part of statistics more over here, which is focused more on these two values, mean deviation and standard deviation. What is the meaning of deviation? Means from any given reference point, how much the value is deviated. That's the meaning. That how much means scattered or difference is there from any reference point. In your syllabus, this reference point is what? Your central tendency. Please check. These values, mean, median, mode, are called as measures of central tendency. And dispersion is nothing but how much difference, how much scattering, the degree of scatteredness, okay, from what, the central tendency which is given to you, whether it is mean or mode, how much it is different or scattered from the given point is called as dispersion. Okay. Now if you take the average of those, it becomes, in cases when you use the variance method, it becomes standard deviation, and you get over here in the case of mean deviation. Quartile deviation, I hope you remember as well. Quartile deviation is nothing but 25% of value is your, basically quartile deviation is deviation from the quartiles. Okay. And what are quartiles? We have total of how many quartiles? 3. 25% is the first quartile, 50% which is the median, second quartile, and third quartile is 75%. So you have total of 3 quartiles. Okay. And of course, so this is going to be your quartiles, and this divides your entire data set in 4 intervals. The first to the quarter 1, then like that it goes. Okay. So basically quartiles are 25%, 50% and 75%. Difference from the particular quartile is called as quartile deviation. Range is what? The uppermost limit minus lowermost limit value is called as range. Okay. So the maximum value minus the minimum value is called as range, guys. Variance and standard deviation. Variance and standard deviation. Now variance, how would you find? So you find variance using what? The formula is there. This approach is there. Means you have to find the individual deviation. The value you see over here, xi minus x bar. X bar represents the reference point. Let's say in this case it can be either mean, it can be mode, it can be median also, depending upon question to question. Okay, so this x bar represents your mean, median, mode, whatever it is, the reference point. And xi minus x bar beta, this value is your deviation. This is your deviation. So when you use this result, you get what? The value of variance. And when you take square root of variance, you get back to what? The deviation, standard deviation value. Standard deviation is given as square root of variance. So if my variance value is sigma square, this value is nothing but sigma. Sigma is not 6 by the way. If you don't know how to read it, it's sigma. It's written something like this actually. Okay, this is the sigma notation. So sigma represents your standard deviation and sigma square is your variance. I hope this is clear. Okay. Now some formulas which is there, same result. Okay, standard deviation is given by, you can see here, same thing over here. Put this value inside the in the root, you get the standard deviation. Now this is when you don't have, when you have a discrete data given where there is no frequency involved, means data is discrete in nature. But if you have discrete data with frequency also, means any particular data is coming 2 times. For example, if I talk about, let's say a student classroom marks, okay, math marks, then there's a chance that 2 students have got 55, or maybe 5 students got 80, right? Then the frequency of each marks, if I'm making, I'll write for 80 marks 5 students got it, 55 marks 2 students got it. Okay, means for each marks which is there obtained by the student in the class, will have a related frequency to it, right or not? Yes. So when frequency is involved, you write the standard deviation like this. Excuse me, sigma fi xi minus x bar the whole square upon n, okay, in the root. And about this, this is the same thing actually. This is the same as this thing, just that this, if you introduce this value over here, this represents your x bar only. Please check. If you bring this 1 by n over here, it becomes what? 1 by n square inside the root, okay? And this whole thing, if I take n over here, this value, if you remember, sigma fi xi by n the whole square, if I have, right, this represents what? The same result actually. Okay, yeah, for continuous distribution, that's for discrete distribution. The properties of variance. So if you add in each data set, if you add some lambda, means a constant value, let's say every data, let's say I have a data set 3, 5, whatever it is, and I add 10 to every of the numbers, 10 plus 3, 10 plus 5 and so on. Will the variance change? No, variance will not change. Variance of xi plus delta lambda, is same as variance of xi when lambda is a constant. But if you multiply lambda over here, then the variance becomes lambda square. And if I talk about the second case only from here, please check. If you say that standard deviation, okay, of lambda times xi, means if in each of the data set, if you have multiplied lambda, then the resulting deviation will be what? Lambda times of whatever it is, standard deviation of xi. So if it is lambda times, if let's say I have the data 2, 3, 5, whatever it is, okay, I'm multiplying 10 to each of the data. Now the new data is 20, 30, 50, like that. What happens to the standard deviation? It becomes 10 times of the original deviation. Let's say I have a data 2, 3, 5, and for this my standard deviation is coming as, let's say, x, okay. Then if I write everything, multiply this by 10, 20, 30, 50. In this case, it will become what? 10x. So in deviation, also you multiply with the same factor, which is multiplying with the elements. In the variance, you got to multiply with lambda square. It makes sense because deviation is what? Square root of that variance. Variance, if you are adding axi plus b, b will have no effect, a will add as a square. A will become a square times of variance. B has no effect. Please check. B has no effect, but a has effect as a square. Same goes with the standard deviation also. Let's look at this question. It says standard deviation of the first 2n plus 1 natural number is equal to what? So for this result actually is what? If I talk about first any, let's say p natural number, okay, then the deviation is given by, sir, root of p square minus 1 upon 12. This is the formula. For first p means 5, 6, whatever it is. For first p natural numbers, the deviation is given by p square minus 1 by 12 in the root. In this case, what is the value of p? 2n plus 1. Please calculate. 2n plus 1 the whole square minus 1 by 12. Expansion please. 4n square plus 1 plus 2 into 2. So 2 into 2n into 1 minus 1 divided by 12. Please check. 1 and 1 cancels. What I have over here, 4 and n is common. Take 4n common. In the first term only n is left. In second term what is left? Just 1 in the root. Please check. So n into n plus 1 by 3 in the root. And that's my value of what? Standard deviation. Option is C. Option is C. The mean deviation of the data 3, 10, 4, 7. Very good question. Okay. So with the data given, the formula for this is actually xi minus x bar summation by what? N. Okay. By n. Let's find x bar first. So we're gonna find mean first. We'll have 3, 10, 10, 4, 7, 10 and 5. Number of element 1, 2, 3, 4, 5, 6, 7. 13, 23, 27, 34, 39 and 10, 49. So 49 by 7. I get the value as 7. The x bar value is 7. Now we're going to do what? To find the mean deviation. This is not, guys, standard deviation. This is a mean deviation, by the way. Remember this, okay? So we're going to find 7 minus 3. Achha, I forgot, sorry. Modulus is there. When we take the deviation, no, we take only the positive value. We don't take the negative value, okay? So modulus is there. So 7 minus 3, how much is that? 4. 7 minus 10, how much is that? 3. Again, 7 minus 10, 3. 7 minus 4, so 3. 7 minus 7 is 0. 7 minus 10 is again 3. And this is going to be 2. What is this? N value again? 7 only. This is this condition, by the way, guys. Okay, as I mentioned, you take the modulus value, not, negative or positive. When you do that, you'll have this as 7 plus 3 is 10 plus 3 is 13 plus 3 is 16 plus 2 is 18. 18 by 7. take the mixed fraction form, 7 2s are 14, over here we have 4. So we're getting 2 times of 4 plus 7, means something which is more than 2 but less than 3. That's my answer. Okay, so this is the end of your one-shot lecture, the theory lecture of the chapter Statistics. I hope you are able to understand that. Okay, the concepts, the formulas, the use, definitions, and some practice also. Okay, done? Yeah. So it's time to solve now the questions, and of course we'll solve some questions, but we'll focus more on your theory part for the chapter of probability. Okay, so let's look at the theory and one-shot lecture of the chapter probability, and of course I brought some questions also. We'll see that as well at the last. Let's start. So starting from the events, of course in this we'll talk about events, different types of event which is there. We can talk about mutually exclusive events, we talk about exhaustive events and all these things. Okay, so types of events, of course elementary or simple events, an event which has only one sample point is called as element of a sample space, which is going to be a simple event. Every sample point in the sample space S forms a elementary event. Okay, for example, if you talk about the examples over here, if you are tossing a coin, for example, if you are tossing 2 coins over here, you have total of 4 sample spaces, HH, HT, TH and TT, means if you get H 2 times and T 2 times, and you get H and T one time, okay, then you have total of 4 simple events, which is HH, HT, TH and TT. Okay, and yeah, that's all. So some definitions are over here as well. Of course you will have the PDF, you can go through that and learn all of this one by one. Let's talk about all of these in brief. So impossible event means events are those which is not going to be happening. For example, if I throw a dice, chances of me getting a 7 is what? A die has 1 2 3 4 5 6 on the all 6 faces of whatever given on 6 cubical faces, right? Square faces, right? So there's no 7 present over here. So if I ask you chances of me getting a 7 of, if you throw a die, what is the answer? 0. It's an impossible event. A sure event is what? Event which is going to be certainly occurring. Okay, certain to occur. It's called a sure event. Okay, so if you talk about throwing at the same die, and for me chances of getting 1 2 3 4 5 6 will be what? Of course 100% chance. So sure, a sample space S is always going to be part of sure event. Okay, means if you talk about the entire sample space, so if you throw a die, what is the sample space, sir? Either you're going to get 1 2 3 4 5 6. So over here same thing goes, as you're going to get what? All the 6 will be sample space, and that is also and always going to be what? A sure event. Okay, so sample space is always a sure event. Compound event which has more than one cases. For example, if I talk about me getting an even number, if you throw a die 2 4 6, this is going to be a case of example of compound events. More than one sample space will be present over here. Now algebra of events. Okay, so this talks about these operations that we have, union, intersection, and of course the difference and complement of the event. So union, intersection we all understand. If you don't understand, you can either remember the formulas or try to use the approach of Venn diagrams. Remember, if I take union, sir, of A and B, then we got to add A and B but remove the overlapping that we have, because when you take A, when you say that event A, do you take this point, sir? Yes. When you say event B, you take this again. Okay, so this is taken 2 times. So you got to remove that. Okay, this is called as union. Same goes in the case of intersection. You just take the common part. Difference means you look for what is present in the set A and not in the set B, and so on. And complement is basically everything but set A. We'll see all of that. So complement of an event is what? So if I say that event is A, complement means A dash. It means everything but A. For example, if I draw a Venn diagram, this is set A, then outside of this will be what? A dash. And if I write this, it is my universe or sample space. A plus A dash is what? Universe. This is what? Universe. Okay, alright, so that's why it is written as S over here. I can write this as S also. This is the same thing. S and U is the same thing. Getting it? Yeah. So that is your complement of event. For example, taken over here we have HH, TT, TH and ST as sample space, and if A is HH, TT means thus A is HH and TT is the event A, then A dash will become what? The other two. If this is A, sir, then the not A will be what? Everything but A in the sample space. We don't look outside the sample space, always look inside the sample space only. So A means whatever is given the event A, and A dash means everything but not A, and you look for that in the sample space only. In sample space, what is not A? So TH and HT, and that becomes your A dash. I write A dash as A dash, AC or A bar. They are the same thing. What is it called as? Complement of A. Okay. The event A or B. What is the meaning of union? I already explained this to you. You're going to take A and B, just remove the overlapping coming ones. That is what going to be over here. So if I write union of A and B, so A plus B, remove the intersection of AB. Remove the overlapping ones, because when you say A, you already taken this part. Okay. Yeah. Alright. So let's say here you can say that 1, 3, 5 and 3, 6 is there, no union. It will be what? 1, 3, 5, 3, 6. Will you write this as 1, 3, 5, 3, 6? 1, 3, 5 and 3, 6. Is this the answer? No, sir. You got to remove one of the 3, because you already taken the 3 over here. There is no copying the event. You will not write 1, 3, 5, 3, 6. You will write 1, 3, 5, 6 only. The overlapping will be removed. Okay. Intersection means you only look for common events. You look for only common entries. Okay. So example, you can see over here. What is common in these two sets? Only 3 is common. That is only answer. Event A. What is the meaning of difference? So whatever is present in A but not in B. For example, if I write 1, 3, 5 and 3, 6, what is present in A and not in B? So 1 and 5. Answer will become what? 1 and 5. If I call this to be my set A and B and take here, answer becomes what? 1 and 5. So what is present in A but not in B? That is called as difference. Okay. Present in A but not B. Okay. Yeah. Some special events, mutually exclusive events, so means when nothing is common. For example, I can write 2 events, right? Even numbers and odd numbers. What is common between them? Nothing is common. Even and odd, nothing is common. Okay. So whenever we write nothing common means we write that as null set. 5. That is called as mutually exclusive events. Exhaustive events, it means if I am writing, let's say, a set. Excuse me, guys. Excuse me. 1 second. Yeah. Okay. Sorry. Pop-up was there. All right. So if you're writing, let's say 3 sets over here. This is my sample space. This is your 3 sets. Okay. Then what happens over here? Basically, so when I'm writing, let's say, the events, okay, then of course I have to include all the possibilities which is there. And if I can take a better example, by the way. Let me take a better example. If I'm writing, let's say, the events like this. Okay, so this is my event A, this is B, and this is C. If I add A, B, C together, I'll get S only. I'll get S only, right? So this is called as A, B, C are mutually exhaustive events. Means if you take union of A and B, means if you take all these events sum, if you take sum of all these events, you get back to what? The sample space. Okay, getting it? This is called as exhaustive events. So if you club them together, you get back to the universe or the sample space. Equally likely events, of course, when the probability of each of the events occurrence is always same. Okay. Addition theorem, of course, the same thing I was writing. Union of A and B is given by A plus B minus the intersection or the overlapping. Okay. If you have 3 events involved, let's say ABC is there, then it becomes what? PA plus PP plus PC. Then remove these two, all of them, all the intersections, and add this particular case. Intersection of all these. This will be added, sir. Okay. And if you talk about mutually exclusive events, then you have to remove this, because this will become what? All 0. So only this will come as the answer. Because if they are mutually exclusive means A intersection B is what? 0. B intersection C is what? 0. A intersection C is what? 0. And A intersection B intersection C is also 0. So if it is mutually exclusive, the answer is simply PA, PB and PC. Otherwise, it's going to be what? Of course, A plus B plus C intersection you're going to remove and add the intersection of all the 3 which is common. Okay. Next. So important results when you take 1 at a time, 2 at a time and 3 at a time. Okay. So basically when you take exactly 1, exactly 2 and more than 2, which is going to be 3 only. Okay. So we'll have at least 2 means 2 and 3. Exactly 2 means only 2 and exactly 1 means only 1. Okay. So when you take 2, at least 2 means you're going to go with 2 or more. So all these 2 are over here and you have taken one of them extra, because usually you're going to be what? -3. We got -3. Please check. In the exactly two cases, we're going to remove minus 3 over here. In exactly one case, we're going to again add plus 3y. Please check. Exactly, we're going to add the plus 3y. Okay. We can take example of 3 sets and get this done. Okay. We can take 3 sets with example numbers and get this verified. Okay. So if you talk about any events, intersection of A and B is always less than event A. Okay. And which is also less than union of event A, B, and which is also less than simply add of the event A and B. Okay. Got it? Yes. Now a question on it. Okay, a simple problem to end the class. So a pair of die is rolled and consider the following events. A being sum is greater than 8. What is possibility of sum greater than 8? Start over here. 3, 6, 6, 3, 4, 5. So I've listed down all the ordered pairs where sum is more than 8. Okay. So it should not be 8 also. 2, 6 is not there. More than 8 means either 9 and more. I can go from 9 to 12. Okay. So 9 to 12 we have gone. Please check. That's my set A. Set B is what? 2 occurs on either of the die. Means if you've thrown 2 die, right, at least one of them has should, at least it should have one of them as 2. We can have both also. So I've written all this important. 1, 2. Then in the case of when you throw the 2, 1, 2, 2, so all this will have 2 in it. And 3, 2, 4, 2, 5, 2 and 6, 2. So these are the ordered pairs where you have at least one. Even in the case of 2, 2, we have both 2. But at least one of the entries or outcome is what? 2. C is what? Sum is at least 7, means 7 or more. Sum is 7 or more, multiple of 3. What are the multiples of 3 with more than 7? So we have 9 and 12. We have 3 3 is 9, 3 4 is 12. We cannot have more than that, okay, because maximum sum of 2 elements in throw of a die is what? 12 only. Here the ordered pairs 3 6, 4 5, 5 4, 6 6, 7 and 6 3. So they are asking which of the pairs are mutually exclusive in nature. Let's check. A and B. What's the answer? What is common between A and B? Please check. Common between A and B. Nothing is common, sir, because in B every element must have 2 in it. In A there is no element like that. So A and B has nothing in common, sir. Answer is 0. This is what mutually exclusive. What about B and C, sir? B and C, again nothing in common, because here at least one of the elements should have 2 in it. Here we have none of the such case. Also null set. What about A and C, sir? A and C have common. 3 6 is common, sir. So 6 3 is also common, sir. And we have 6 6 common. Actually all of them are common. 4 5 is also common. 5 4 is also common. Please check. All these are common, sir. Okay, 6 3 is also common. So all of these are common actually. So if I ask what's the intersection of A and C, is simply the set C. Intersection of A and C common, what is common? So simply the set C is common. Please check. Set C is the common set. So this is not going to be mutually exclusive. Only AB and BC are giving you null set or 0. So answer is AB and BC. A is the answer. I hope it is clear, guys. Yeah. So this is the conclusion of a one-shot lecture of the chapter. Probability. Okay, so I hope you have learned from it. Please try to revise it one more time if you have to, and solve the question also again. That's all from this particular class. I'll see you in the next one. Till then, take care. Bye.